Satellite communication, question 2. A satellite is positioned 36,000 kilometers above the Earth's surface, as shown in the diagram. Part A. If the footprint has a radius of 3,000 kilometers, calculate the angle theta for 2 marks. Well, this is the angle we're trying to find. The radius would be from the outside edge of the footprint to the center, and so we can draw a right-angled triangle where this angle would be theta over 2. This is the radius of the footprint at 3,000 kilometers, and this would be 36,000 kilometers. Now we can use sine here, as with these dimensions the hypotenuse is going to be pretty much the same at 36,000 kilometers as the adjacent. And so sine of theta over 2, sine is opposite over hypotenuse, which is 3,000 over 36,000, or 0.083, giving theta over 2 of 4.8 degrees, and so theta will be twice that at 9.6 degrees. Part B. If the signal has a wavelength of 15 centimeters, calculate the frequency of the signal for 2 marks. Well, the datasheet tells us that wave speed equals frequency times wavelength, and so we can rearrange to give frequency is wave speed, in this case c, the speed of electromagnetic radiation, over wavelength, which is 3 times 10 to the 8 meters per second, also on the datasheet. Wavelength we must convert into meters of 0.15 meters, giving a frequency of 2 times 10 to the 9 hertz, or we could write 2 gigahertz. Part C. Assuming the limit of the footprint is at the diffraction minimum, calculate the diameter of the satellite dish transmitting the signal for 2 marks. Well, on the datasheet we're given the formula that the half beam width sine theta is equal to lambda over A, where A is the transmitting dish diameter. Rearranging, we get that A is equal to lambda of 0.15 meters over the sine of half the angle, which is sine 4.8, gives us a dish of diameter 1.8 meters. Part D. Will the Earth-based dish that sends signals to the satellite be larger or smaller than your answer to Part C? And explain. There's only 1 mark for this. It's unlikely you'd get a mark for saying larger or smaller. The mark would be for the explanation. Well, the ground-based dish would be larger, because the larger the dish, the less diffraction, and so it will be able to focus more energy onto the satellite, meaning a lower power signal can be sent in the first place. Part E. Explain how the satellite is able to send many different signals from the same transmitter simultaneously, and what are the advantages of this system. Well, there are 5 marks here, so we need quite a lot of detail. Firstly, the system is called time division multiplexing. It involves sampling the signals and transmitting them in binary code. Each signal is transmitted in a fraction of the time. The signals are then transmitted in turn and sorted out at the other end. There's a reduced cost or weight over having multiple transmitters. Particularly as this is on a satellite, it would be very difficult to put many large dishes on one satellite. The system is more secure, as the signal would need to be decoded. With sufficient bandwidth, we could have very many simultaneous signals, many thousands in some cases.